Good morning, everybody. So yesterday, last time we looked at this adapter classes. We said that in STL both stack and queue are adapter classes. They are only kind of an interface. Under the hood, they use the vector class, or I think in the STL implementation by default it uses the deck. We talked about this, and we talked about usually we use it like this way, like a stack, integer stack. But sometimes if I like, I can change my class that I use as a workhorse. Okay, so that was it. If there are no questions about it, let me move on to associative containers. So we looked at the sequential containers, which are vectors and lists, forward list, deck, and that kind of stuff, sequential containers. And we looked at adapter containers, two of them. Now we are looking at this associative containers. The meaning of associative container is, you may think it as a simple database. What's a database? Database is usually you show it something like, you're gonna learn it later, maybe you know it. Okay, so this is my desk. Okay, this is my database. You ask questions. You say that, okay, give me the person that has this TC kimlik numarası 171570711, etc. Okay, so, and it will give you a person, okay, name, last name, etc. So all the person information. So the databases are like that. Okay, so you give the key. This is the key. Okay, it returns you the value, key value pairs. Okay, in this case, value is a large object, key is a simple object, and that's it. Associative containers kind of implement this idea. Okay, so you provide the employee's social security number as a value, as the data. You get the employee's record as a struct. Okay, so you provide the keys and you get the rest. So STL implements this idea in a number of classes. The simplest one is the set class, set template class. Set template class, set, as you know, is küme in Turkish. Küme in the mathematical sense. Okay, küme in Turkish. Set class is an associative class, but it is special. It doesn't have any value parts. It has only the keys. Okay, it has only the keys. So it just stores elements without repetition. You say that I have a set. Okay, put these, let's say, integers in it. Put 1, 7, 8, 11. Okay, I inserted 4 of them. If I like to insert 11 again, the set says that no, I don't allow any repetitions. Okay, because I already have 11 once. You cannot store 11 more than once. Okay, you cannot store 11 more than once. As you see, you may ask the set, do you have 7? It says yes or no. It says yes or no. Okay, so you add element, you delete element, you ask if the element is in the set. That's the basic stuff with the sets. So do you think, what kind of iterators do you think we have with the sets? Do we have random iterators, random access, such as index operator? Do you think the index operator is available with the sets? Yeah, I mean, there is no point in accessing these elements by order, and in fact, the sets don't have order, okay? Because order doesn't matter for the sets. There is no index operator with the sets, okay? But there is an iterator, and you could use iterators to list the elements one by one. If I like to go over the elements of a set, you could use it that way. Okay, let me show you an example of a set from our book. Where is this the set? No, this is list. Yeah, okay. This is a stack. Okay, we have seen this yesterday. Here is a set. Okay. Set of characters. Set of characters. I insert an A, then D, then another D, then C, then C, then B. And after that, when I run this code, you will see that, okay, as you see, I have an iterator, and this iterator is a forward iterator. So it has an iterator, it's a forward iterator. And okay, let me put the indentation right. Okay, so I iterate over the elements one by one. As you will see, this will print only A, D, C, and B, not necessarily in that order. Okay, it will print only A, D, C, and B. It will have only 4 elements in it. If you look at the size of the set, you will see that there is only one. There are only 4 elements. Even though I try to insert 1, 2, 3, 6 elements in it, 2 of them are repetitions. I cannot insert D more than once. Okay, that's one thing. I am using the iterator. The other thing is, what did we say about the sets? We said that we add elements, we delete elements, and we ask if the element is in the set. Let's see. Okay, how do I do that? You say, okay, s.find. Find makes a search on the set. If it finds the element, it returns a iterator on it. Okay, like a constant iterator. If it doesn't find it, okay, it will return the iterator, but that iterator will point to end of the set. Okay, so s.find is going to return an iterator. That iterator will be the same as s.end if the element is not in the set. So here I would say no, and I would say yes. And finally, we will say just erase C, okay? And after erasing C, I run this loop again. Okay, I run this loop again from beginning to end. By the way, I mean, for this kind of stuff, this notation is much better. Range for loop. Okay. Auto E and S, and I would do E. That E means element. Okay. So you don't have to write the whole thing. Iterator. This range for loop is doing the iterator by itself already. So try to use this one as much as possible. It is efficient, and you don't have to type lots of stuff. Okay. So it will list all the elements of the set, but C will be removed in it. Okay. And after that, if I run this, if I run line 37, you will see that C no longer belongs to the set C. Okay, let's go to the set documentation from C++.com, and here are the begin and begin end, and these are the usual iterator stuff. Capacity, size, max size, insert, erase, and clears everything. Okay. So we looked at those. And these are the operations. Count elements with this specific value. Okay. I am not, as I said, I am not going to go into the details of it. Most of them I don't remember. I don't remember how count works because set, well, I don't want to go there because if I go there, it's going to take at least 5 minutes. But one thing that I like to mention here is this. This template, okay, this is the template class of the set, character set or the string set, whatever. There is a compare class here. This is last T. Okay, so the book slide says that, okay, set can take an ordering. Okay, this ordering is important in case that, okay, your set doesn't have to be ordered, but this set example, this set implementation keeps them in an ordered way. Okay, so how do I do the ordering? How do I determine the ordering? The default meaning of ordering is less than operator. Okay, it uses the less than. So, but I can change it if I like. How do I change it? This is how you do it. Okay, by default, this less t is the ordering mechanism. Let's look at this less t. What is less t? Less t is, okay, less t is a templated, less t is a templated, not a class but a struct, but doesn't matter. Okay, so less t defines an operator function call. Okay, and this operator function call takes two arguments and it returns just x less than y. So if you say less t of integers, it will just define this, and inside this struct you will have a function call operator that will take two constant t references and it will return x less than y. So by default set uses this less than operator. If the less than operator is not defined on your objects, so if you have a set of, let's say, set of p f array integer objects, okay, you will have a compiler error. Why? Because the less than operator is not defined on these pf array objects. Okay, it has to be defined. Okay, good. There are other versions of sets. If I go back, where are the, okay, this is less. Okay, go back to the set stuff. Okay, unordered set. There is an unordered set. In that case, this unordered set doesn't need any ordering information. Okay, it just needs the key. That's it. Okay, it uses this hashing operation instead of sorting. Okay, and that's it. And you don't have to specify anything about this hashing if you don't know anything about hashing. That you will be fine. By the way, this unordered set is C++ 11 thing. Before that, there were some other solutions. Okay, Mehmet has a question. If you want to find last element, can find to this. Mehmet Hussein, this okay. S dot end doesn't show you the end of the set. It shows you beyond end. Okay, let's say this is my vector. Okay, let's say this is a vector v dot begin points to the first element, v dot end points to one element past the last element. Okay, v dot end doesn't point to the last element, it points to one beyond the last element. That's why we had a problem with the reverse iterator. Somebody asked, why don't we start from the v dot end and come backwards? Why do we need the reverse iterator? This is one of the reasons why we have reverse iterators. Okay, so this is a set example, and this is the example that I gave you. I think this one gives you okay, this is the output. At the beginning, I have 4 elements in it, and I ask if C is there. Yeah, it is there. After reading it, I have only 3 elements, and the elements are kind of sorted. What kind of iterator do I have for the set? Let me see what kind of iterations I have for the set. This is unordered set. Let's go to the set again. Multiset is a set version, okay, but it allows you to insert the same element more than once. Okay, it allows you to insert the same element more than once, so it is not a standard set. That's why we call it multiset. So let's go to set and let's see the iterator types. Okay, begin returns an iterator at the beginning. Let's see the iterator. So iterator is a bidirectional iterator. So that means I can go forward and backwards. Okay, it is bidirectional. Here, bidirectional. I can go backwards and forwards, but random access is not there. Okay. Good. Okay. As you see, the documentation is important, so important. Instead of looking at headers, I usually find my information from the documentation. So writing documentation to your classes, to your libraries, is as important as implementing them, because without a good implementation, your customers will be in a very difficult situation. The set class, vector class, stack class, they are all very nice classes, but without the documentation, there is no way I can remember all this stuff, right? I will forget, okay, the details and everything, okay? So it has to be complete. Remember that the bit set class, it missed this invalid argument exception. So that's a bad documentation. If I miss that one, my code will be vulnerable to those kind of problems, because there is an exception thrown out of the constructor and I don't know about it, and I don't write any catch statements accordingly, and that will put me in a very tough situation when the customer experiences that exception. Says that, okay, I'm getting an exception from your class, and you don't put this in your documentation. That's going to be bad. Okay, go back to the slides. Okay, let's go back to the associative containers again. What did we say? Associative containers are like value. You give the key, it gives you the value, right? That's the thing. Set is a special associative container because it only deals with the keys. It doesn't have any value parts. So you say that, do you have this key? It says yes. Insert this key. I will insert it. Okay, remove it, I will remove it. Where is the value part? It doesn't have the value part. So the set is a simple associative container. Let's look at one complete associative container, which is called map template class. Okay, map template class keeps key value pairs in your database. Okay, it keeps key value. So I have a special map here. The key part is a string. The value part is a integer. And remember my example. The key part was the social security number, and the value part was the person. But in that case, my map would be map of string would be my social security number, and person would be my value part. So string would be key and person would be value. Okay. So let's see an example actually. Let me go to the... Okay. I'm going to use map of string planets. Okay. I am going to keep information about the planets in our solar system, and the key part will be a string and value part will be a string too. Look at this one from 14 to 22. Planets is my map. For indexing, I am using the index operator. I am saying that, okay, the key for this one is Mercury, and the value is going to be a hot planet. Mercury is hot because it is the closest to the sun. Okay, it's a rock again. Venus is the second one. Atmosphere of sulfuric acid is the explanation for that one, the value part. Earth is home. Mars is a red planet, and the rest of them are all giant gas planets. Okay, good. Okay. These are all indexes, and indexing with the maps are fine. We could do that, and anytime you like, you say, give me planets Mercury, and it returns you this hot planet. It is convenient, right? So as you see, I don't use any insertion. I didn't say insert. I didn't say I have this many elements in it. All I am saying is just using the index operator to insert some stuff. And like the sets, the find member function works. It returns an iterator. Iterator will be planets end, or iterator will be pointing to the right element on in the map. Okay. Again, a constant iterator. I can iterate over the elements of it. This is interesting. Okay. This iterator will start from beginning to the end. Each time iterator will point to the element of a map, but the element of a map is a pair, key value pairs. The first is going to be the key, and value will be the second. So the first is an element of this map, and second is another element. First is the key, second is the value. And if I run this, I would get these results. Okay. This one is for this one. I think this one is for planets. I guess Mercury. Okay. And this one is for planets that find, right? Mercury, I guess. No. Yeah. Let me remember the code again. Was it Mercury? Yeah, find Mercury, yeah. And then the series. Okay. And then this is the iterator. As you see, the elements are not in order. I mean, their order is not the same order that I gave them. I think it keeps them in alphabetical order. Again, the ordering is important with the regular maps. Let's look at the documentation of the maps. It's going to be like the sets. Okay, it's going to be like the sets. The first element will be the template key. Okay, then the value and key value and the comparison. Okay, this is for ordering. Remember, I had the same thing with the sets. So this one will take 2 parameters, but if I like, I can provide a third parameter for the ordering relationship. Ordering is important for the map. If I don't like this, if I don't want to use any ordering because I don't have the ordering information, then what are you gonna do? Like the PF array, we don't have the ordering information for PF array. What are we gonna do? I like to use the map of PF arrays as key. What am I gonna do? What would you do? The same thing. I like to use the set class for the PF array class. Okay, set of PF arrays, but PF array doesn't have ordering information. It doesn't have less than operator defined. Okay, one thing would be, okay, I can define a less than operator, but how do I define it? Doesn't make any sense to write a less than operator for an array, right? So what should I do? How can I use sets of PF arrays? Anybody? Cheval, you tell me. You have an idea, I know. Cheval, I am waiting for you. You don't what? Just give me something. Do you understand the problem? Okay, tell me the problem then. What is the problem? Use your microphone. We can't wait for you to type. Anybody else? How can you use sets on PF arrays? PF array doesn't have less than operator defined. Not a single person is listening to me. I gave you the answer 5 minutes ago. Oh, this is not good. Maybe we can give the key of the last one. Well, we are trying to do this. We are trying to have a set of PF array Ds. And I don't have anything other than this key. Or similarly, I like to have a map of PF array D, and for each PF array D I am going to store, I don't know, it's a stupid idea, but I like to do this person. The C++ compiler will tell me that this is not going to happen because the less than is not defined for this PF array D. Well, yeah, that's what I said. Maybe overload the less than operator for PF array D, but what if PF array D is not my class? I don't have the source code. Okay, even if I have the source code for the PF array D, less than doesn't mean anything for an array. Okay, less than doesn't mean anything for an. How would you sort a PF array D arrays? Okay, array of PF array D. You cannot, because I don't know which one. I mean, there is no meaningful way to implement this less than operator. So the answer is, like I told you 5 minutes ago, there is another class named Unordered Set or Unordered Map. This Unordered Map is a map class, but this one doesn't need the ordering information. Okay, you could use unordered map. As you see, it doesn't need any ordering information. This is what I said exactly 5 minutes ago. Nobody is listening. Okay, let's go back. So this map needs all of them sorted, and it uses a string sorting. As you see, when I print them out, they all come back sorted with respect to the first key, string sorting, less than. Okay, so that's the map. So I think we looked at almost all the containers. Okay, deck, forward list, map, queue, set, stack, unordered map, and vector. I don't remember what is the difference between the vector and an array. Array is a new thing again. Array, okay. Fixed size array, okay. So it looks like array doesn't change its size. So it's for efficiency, I guess. Fixed size sequence contains the specific number of elements ordered in a strict linear sequence. Okay. So how do let's look at the, okay. Oh, okay, see? This is a nice example of a template that uses an integer as a template parameter. So you fix the size at the compile time. There is no way it can change. So the compiler can do optimizations regarding the array usage. Okay. Well, you might say that this is exactly the same as C arrays. Why do we need this then, right? Why do we need this? This is exactly the same as C arrays. Why do I need that? Because C arrays are their sizes are fixed during the compile time, right? We don't change them. Only with the dynamic arrays I change them, but with the arrays we don't change them, regular arrays. Why do I need them? I need them because this is STL class, and there are lots of stuff like the iterators that I can work with the STL stuff. Okay, so this is good. Okay, let me see. Unlike the other containers, swapping into arrays containers, then is that okay? Value. Let me see if I can see any interesting. No, everything is fine. Okay, so that was it. So we looked at all of them. This completes our iteration over the containers of all the STL classes. Now let's go back to our slides, and as we have seen before, I could use the C++11's range for loop. Okay, range for auto is something that we use all the time. Initialization of the templates, okay, STL classes like this, like a regular arrays are fine. We could do that. Initialization can be done that way. No problems. Okay. So if you are using that STL arrays class, okay, all of them are possible, including the range for loop. Well, if you remember, the range for loop is possible with the regular C arrays too, but if I send that array to a function, it is not an array anymore. It's an integer pointer, it's a data pointer, right? In that case, range for loop will not work, but with the STL arrays, it will work. Also, STL arrays, they know their sizes. Okay, they know their sizes. So how do I use an STL array? I use, what was the name? The name was array, right? So you would say capital I, yep. No, not capital. Okay, you would say array of integers, and I need 100 integers. Okay, my array. This my array knows its size, and I can send this array to functions using references or pointer or call by value, doesn't matter, and it will know its size. Okay, so instead of using regular C arrays, you could use this one, and this one is going to be very efficient because as I said before, the size is fixed during the compile time, and efficiency will be guaranteed by the compiler if the compiler is smart enough. Good. Any questions? Any questions? Okay, if there are no questions, then I will continue. The book talks about the efficiency stuff. I am not going to talk about this much because this efficiency of these classes and the algorithms is the topic of the data structures and algorithms course next semester. So maybe I will talk about it a little bit. But other than that, instead of talking about the efficiency, I will talk about the standard STL algorithms. Okay, STL provides us some algorithms, and some of them are, see, STL, with the STL, I have these classes and these classes containers, and for those containers there are algorithms. Okay, Let's look at those algorithms. These algorithms are all valid for almost all the STL classes, and I am going to look at some of them, and most of them you can guess. For example, there is a find function. It's a global function, find function, and it will work on the STL classes. Let's see one example. Okay. Find says that I am a function. I will take two iterators, the beginning of a position, the ending of a position on a container, and that the value that you are looking for. Okay, that's the idea. And let's see the example here. It uses a regular array of size 4, and it says that find the value 30 and return me a pointer on it. Pointer is in this case, my iterator, right? Okay. And if the return pointer is not my int plus 4, which is the end of the array, then I found it. Otherwise, I did not. I could do exactly the same thing with a vector of integers. Okay. This vector of integers will take this my int as the initial value, and I have an iterator on it. Okay, I call this find function. As you see, find is a global function. We don't like global functions in object-oriented programming languages, but in STL, we have these kind of functions. Okay, and find will work on all kinds of STL classes, including the basic arrays. Okay, that's find. And instead of using a vector here, it could be a set, it could be a map or stack, or could it be a stack? I am not sure. Let's see what kind of iterator it needs. Because no. Stack will not be good because stack doesn't have the iterators, right? It could be map, it could be set, it could be forward list, it could be a double list, but the queues and stacks are not applicable for this find. So find is just one example. What else do I have other than find? There are many versions of find. For example, find if it finds something depending on a condition. Let's see the example. Okay. First and last, and it says that I need a unary predicate. It is not looking for a specific value, but it is running as an if statement, something like that. Okay, let's see. Let's say I have a vector of integers. I inserted 4 values in it, and I am going to run this find if function. Okay. I say that from beginning to the end of this vector, run this function is odd. Is odd is looking for odd integers. Is odd is a function. It takes an integer. If the remainder of this modulo operation is 1, then that's an odd integer, right? It's not an even integer. It's an odd integer. Okay, so this find if is not looking for a specific value. Okay, it is running this function is odd on all the elements of the container. That container might be a vector or set or a map or a list, doesn't matter, and it will find you the first element in that vector that this function returns true. This one is called predicate function. You gave it a function, okay, predicate function. Here is the usage. Iterator begin, iterator end, and is out. As you see, there are many examples of algorithms under the algorithm header, and the book kind of discusses that. Genetic algorithms and sorting algorithms, counting algorithms, and etc. I will not talk about this runtimes, as I said before, but I think this one gives an example about find function. It's a vector of characters. I will put these characters inside the vector. Then I will call this find function. I am looking for this E. Okay. Whenever I find that E, whenever that find that E, okay, I will run another loop that will start from the beginning of the vector until it finds that value E, and it will print them up to that point. Okay, question. What happens if it doesn't find any E's in my vector? What happens if there are no E's?
Maybe runtime error.
Say that again, Mehmet.
Runtime error.
No. What happens at line 22 if there are no E's? What happens at line 22?
It returns end of line.
Yeah, line.end, right? So where is pointing to line.end, right? And when I do this, line.begin, line 26 now, line.begin to line.end, right? So it will print everything in that, vector, right? So there are no runtime errors. So Anil Mert, what you are saying is not correct. So where will not be -1? Where did you get that idea? Where is going to be line.end? Find works that way, right? Find returns a iterator. That iterator will point to the position of E. If there are no E's in that vector, where will point to line.end. That's the definition of find. I told you a few minutes ago. So this will print the whole vector. And this one will print what? This one will print all the elements after E. If there are no E's, where will be the same as line.end? So this will not print anything. Okay, so enter a line of text. They entered. So E is here. The first part will print a len, then the next part is E of text. And second iteration, I am running this again. Enter a line of text. I will not. There are no E's in it. The first part will print I will not. The second part will print nothing. So it will work no problem. Okay, so this fine kind of stuff, they don't modify anything. Okay, there are some modifying sequence algorithms, such as inserts and deletes and that kind of stuff. Okay, but we need to be careful. I mean, if you are using modifying algorithms, then your iterators will be messed up. Okay, if you have an iterator that is pointing to some element and you delete it, that iterator is going to be messed up. So you need to be careful about those cases. Sorting is there. Let me see. Do we have any? Yeah. Do we have any examples about sorting? No, but I can, of course, go to the algorithms, and I have the search. I have the sort. Okay. So sort is a function. It takes two iterators. But what kind of iterators? Random access iterators. So the sort is going to work only on random access containers such as the vector. I think list is not a random access. Yeah, list is not a random access container, so this sort will not work there. Okay, let's see an example here. My integers and my vector. Okay, I have a vector that are initialized by my integers. By the way, I think line 14 we did not do anything like this before. I have a vector and I am initializing it with a standard C array. This is the beginning of the array. It's a pointer, and this is the array where I like my, okay, between this position to this position, 8 elements of this array will be copied into my vector. And I use, as you see, I use my sort like this. How come this works? Can anybody tell me how this works? What is this plus? What is this plus here? Whose plus operator is this plus? Iterators, right? Remember, the plus operator works for the random iterators. Plus operator works for the random iterators. And if I load this page again, and if I go to random access iterator, where is this random access? I'm trying to find a link for the random access iterator. Random. Yeah, here it is. So the random access iterators are like these. I have these plus minus, they will all work. Also less than, greater than, and plus assignment, minus assignment, etc. They all will work for the random access iterators. So this one says that from beginning to the fifth element, right? Sort. Or from the fifth element to the last element, just sort. In this case, don't use the less than operator, but use my function to sort stuff, to make the comparison, my function. So sort has an overload that takes this function. Let's see that overload. Overload is here. Iterator, and comparison. Okay, class compare. This one. Okay, compare is of type a function pointer, and I am providing my function pointer here. Okay, my function. And what is my object? My object is an object of this class, my class, and this my class has a function call operator. Where did I define my object? Where is my object? Oh, okay, my object is here. Okay, we never did that, but yeah, it works that way. Okay, so this is for sorting. Again, sort is a modifying algorithm. Sort is a modifying algorithm. What kind of sort it is using, I don't remember. Sorts, is it a merge sort? Let me see. What kind of sort algorithm is this? complexity. Linearity in the distance in the width of the performs approximately n log n, where n is comparison up to then swaps up to that many element swaps or moves. It doesn't say about the algorithm. Maybe it is using a specialized algorithm. Okay, so that's not the end of the discussion of our STL, of course, because there are many things that we didn't do. See, all these algorithms, these are all defined. Okay, and when you look at them, some of the functions are the names of some of the functions are self-explanatory. No problem. Copy is going to copy from range to another range. Equal is going to return a true, false stuff. Fill again is going to do that kind of stuff. But some of them are not that evident. Okay, let's look at this for each. For each is a very common one. It is used by many other programming languages too. So you need to be ambitious, and you need to read this kind of documentation. So for each is going to perform some operation for each element of an container. I have a vector. I have 3 elements. Okay, this one says that run my function for each of the elements from beginning to the end. What is my function? My function takes an integer and prints it. Okay. So what is this going to do? It is going to print all the elements of this vector on the screen, either using this my function as a pointer, or it's going to use this function call operator inside my special class. Okay, so that was another example. Is sorted nice? Yeah. Is permutation? No, that's interesting. Anyway, no, I'm not going to go in there because that will take me lots of time. So that's it for the discussion of STL. For the remainder of this class, I will talk about shared pointers, which we call them as smart pointers a little bit. Then, as the time permits, I will talk about move semantics. Okay, so let's take 10 minutes of break, and after the break, I will talk about these 2 topics. Mohammed, can we connect? Can we what? Mohammed, can you
Connect. I'm right.
Can we connect?
Algorithm with that. For example, for each dot range.
For each dot range? I don't. No. You need to explain it. I don't understand what you say. There is only one function named for each, and it doesn't look like it doesn't have any different versions of it. What do you want to do?
I mean, sir, we have a vector. We are using it sort. Then connect with dot for each.
What is connecting?
I'm typing.
Okay, I'm going to edit this program just to try to understand what you mean. Okay, here's my program. What is this stupid thing? This is cpp.sh? So, oh, that's so nice. I didn't know. I think they added it later. For each dot sort. For each is a function. Mohammed, for each is a function. See? For each is a function. Templated function. How can you say something like this? Okay, if I have a function like f, how can you say anything like sort? F f should return something like an object. Okay, and on that object maybe sort is defined. Maybe you could do that, but in this case, for each doesn't return anything. Function for each. Unary function that accepts, okay. Return value returns fn. I don't know what fn is actually. So I don't understand exactly what you mean and I don't exactly did not understand what you try to achieve.
Okay, so thank you.
Thank you. I didn't say anything. So what are you trying to do? I don't understand what you are trying to do. I mean, if you like to sort and then run for each on of them, yeah, you could do, but you have to call sort first, then for each later. And sort and for each are two different functions. Okay, are two different functions. Sort first, then call for each later. Maybe you're trying to do something like this. But in that case, G or F should return something meaningful. Okay, if there are no other questions, let's take 10 minutes of break. Let's be here around 09:54, and I will talk about the shared pointers, and I will talk about move semantics. That's going to take maybe 40 minutes, so I will take a little bit more time.
Hocam, can I ask something about efficiency?
Sure.
Since an array arranges its size in the compile time, can we say it's the most efficient container?
We can say that it is the most efficient container in terms of memory allocation, but I cannot say that it is more efficient than the vectors when it comes to index access, because it is the same thing. It's a very lightweight class, okay, and the compiler has the option to optimize it if the size is right. Other than that, it doesn't have to deal with resizing and that kind of stuff. I mean, efficiency has some. You cannot say that this is the most efficient class, because with the classes, for example, let's look at there. I think there was a discussion somewhere. Where is it? Yeah, okay. Vector is very fast, okay, when it comes to inserting elements at the back. Okay, vector doesn't add element to the front. Okay, but vector is very inefficient if you try to insert elements in the middle. Let's say this is your vector. If I like to add elements to the add, it is very fast. It is as fast as possible. But if you like to add elements in the middle, it is not very good. Okay. Okay, in that case, it is ON. O1 is the fastest. ON is not that fast, it is slow. O1 means that I am going to do, this is very crude approximation, but explanation, but just take it this way until the next semester. O1 means that you are going to do just one operation. ON means that you are going to do n operations. If the size of your vector is 100, you are going to do up to 100 operations. O log n means that if you have 1024 elements in your array, you are going to do 10 operations, because logarithm of 1024 is 10, right? So O1 is the best, then this one, in terms of efficiency. So vector is very efficient if you are doing the insertion at the end, but vector is not that efficient if you are doing the insertion in the beginning or in the middle. Okay? Dict and list is very efficient wherever you add your number, okay, or your element. Okay, so that's the efficiency. When it comes to the sets, inserting to a set, okay, ordered set, this one is an ordered set. Insertion to a set is log n. So it is a little bit faster than vectors. Well, it's a lot faster than vectors, but it is slower than lists and dicts.
Okay, thank you.
Okay, so you wouldn't say the most efficient algorithm here is there. No, I can't. Efficiency has some properties. I mean, efficient in terms of what? Well, array is very efficient because it doesn't let you insert anything, right? It doesn't let you insert. By the way, by inserting, I mean that adding a new element. I am not talking about replacing this one. I am not modifying the element. I am just adding a new element in between these two. Okay? That's the insertion. So there are insertion, there is search. Okay? When it comes to search, set is the most efficient. Why? Because it takes O log n time for the set or map. It is very, very fast. But when you do the search on a vector or on a list, it will take O n time. So when it comes to search, set is better. Set is going to be much faster than array. Okay, array is going to be slow when it comes to searching. Okay, so let's come back here. Let's come back here at 9:54. Let 9:54. Yeah. Okay. Okay, class. So let's start talking about this shared pointer. Shared pointers are, some of you will get mad at me because I did not teach you this before. Shared pointers are kind of an answer to the critics of C++ that say that using pointers are so difficult. You have to remember to delete them. You have to remember to, after allocation, you have to be very careful about the deletion and the collection of the garbage and etc. Shared pointers are something like this. They are something like this. Suppose I am using a new operator to make a new object, money object. Okay, how does this work? In my memory, there will be a money object, and inside the money object, it will be $10.05. Okay, with the shared pointers, there is this idea. Okay, if I have created this money object using the new operator, it puts a new field in my money object, which is the reference count. Okay, reference count. How many pointers are pointing at me? Okay, I am going to do this now. Okay, let me try to write this a little bit smaller so that I can make changes to it later. Okay. So I have my shared pointer. Shared pointer of money. Come on. Okay, I'm going to write this again. Okay, I have a money pointer, and my pointer is going to be P, and the initial value of this pointer is new money $10.05. So there will be two objects. One of them is P. P is pointing to this one. Since P points to this money object, its reference count will be 1. Okay? And when I do declare another shared pointer, let's say shared pointer, again a money pointer, P2, and if I say P2, the value of P2 is the same as P, then P2 is going to be here, and P2 is going to point to the money object again, and this counter will be 2 now. So the objects created in the heap in the dynamic memory know how many times they are referenced. Okay, how many times they are referenced. Let's say I did this in a function, void f. Okay, I did this in a function, void f. After this function ended, what's going to happen? You just tell me. Both P and P2 will be deleted, right? P will be gone and P2 will be gone. When they go, they are not pointing to this object anymore, right? So this count will decrease to 1 first, then it will decrease to 0. Since I ended this function without deleting this new money object, right? It looks like it's a memory leak, but it is not. Why? Because this object is now smart enough to delete itself because nobody is referring to it. Okay? Nobody is referring to it. So you don't have to delete any dynamically created objects if you are using shared pointers. So with the shared pointers, you just create your objects on the heap, okay? But be careful to use that pointer to initialize a shared pointer. And you do your assignments, and you can do anything you like. For example, you could do P2, arrow get cents. Okay, and I can print this out if I like. Okay, so you could do anything like that, or you could say call another function g dereference p. That means that you are sending this money object using call by value to a function named g. That will work. So anything that works on a pointer will work with the shared pointers. Okay, but you don't have to remember to delete your objects, because object deletions will be done automatically. By this smart buzzer. Sometimes we call them smart pointers. Deletions will be done automatically by these smart pointers or the shared pointers. Okay, good. Any questions?
Can we use this instead of all the pointer we used before? I mean, is there any reason for not to use this shared pointer?
Are you asking me why I have wasted your youth? Are you yeah. Well, yeah. See, the Bahadur has an explanation again. Yeah. Is it expensive to use shared pointers? Well, the one of the reasons why you might prefer using classical C pointers is the efficiency, because every time I am doing this assignment, what happens when you do this assignment? It will go to this object and it will increment the reference count by 1. Okay, and every time I kill a pointer, it will go to the referenced object and it will decrement it, and it will check if it is 0 or not. Okay, if it is 0, then it is going to delete it. So these kind of overheads will be there. If you don't like this happening, then you would use the classical C pointers. Otherwise, shared pointers are perfectly fine. You could use the shared pointers everywhere that we have used so far. Okay. The other thing could be this. The other thing could be something like that. Let's say I have a class. I have an object. Okay. Inside this object, there is a shared pointer. It is pointing to some other object. Okay. Okay. So the reference count of this object is going to be 1, right? If this one is pointing to this one, the reference count of this one will be 1. And nobody else is pointing to these two objects. This means that it's a memory leak, right? It's a memory leak. Why? Because there is no way that I can access this object or that object, because this reference count is 1 and reference count is 1. Nobody is pointing to this one. If somebody is pointing to this one, this would have been 2. No. So, well, I mean, these kind of stuff are can happen, and if this kind of stuff there is a possibility of happening, then it is wiser to use some other mechanism other than the shared pointers. I mean, in that case, you need to do your own deletion of the objects. Okay. So if I like to convert my previously implemented PF array class, do you remember the chapter number of the PF array? Maybe it was in the templates, right? Templates are chapter 18. No, chapter 18 is exceptions. Chapter 17. Do you remember the chapter number for the chapter 16 maybe? Yeah, okay. PF array. Let's go to PF array and PF array implementation. Let's open them. See, this guy has a T, okay, T pointer. Now let's make this shared pointer. If I can find the shared pointer T, and let's make this A, okay. Okay, that's the, I think that's the only thing that I am going to do here. So I am keeping a shared pointer, and then I am going to go to the implementation and do some changes. Okay, so E is a new capacity. Okay, that's fine. And then I have all of these. These are all news, new. Okay. No problems. So I am going to find these delete statements. Yeah. So I don't have to do this anymore. Just erase it. Because when I assign a new stuff to A, the old one will go automatically, and this one I don't have to. So I don't have to remember these. Okay, so deletions are gone. So pointers are like maybe more like integers now. I do assign them and etc. that kind of stuff. Let's look at the let's look at the documentation of this stuff. Where is the documentation? Documentation, I just opened it. Okay, no, not that one. Shared pointer, here it is. Okay, shared pointer documentation is here. Class T, just a shared pointer. And these are the these are operator dereference is defined. Arrow operator is defined. See, you could say, what is my count? How many users do I have? Okay, it will tell you. Okay, unique, am I the only one pointing to this object? Am I unique? Okay, am I pointing to a null? Okay, am I null or a shade? Okay, this is the overloaded assignment operator. And let's look at this. I think there was an example here. Okay, good. So there is a class show. Okay, there is a class show. There is a class A, and inside the class A there is a function show. It doesn't just print, it doesn't do anything, just prints it. Prints a message, that's it. So I have a new shared pointer, P1. Okay, and I assign the new object to it. There is a new operator here, but you won't see any deletes. Okay, so first, I call this p1.get. What kind of thing is this? Okay, p1.get. It looks very strange to, it's very weird to my eye that I used both dot operator and the arrow operator on the same object. How could this happen? How could that happen? If it's a pointer, I would use an arrow operator. If it's an object, I would use a dot operator, right? That's how we taught you. That's how you learned it, right? If it's an object, you use the dot operator. If it's a pointer, you use the arrow operator. It looks like I am using both the dot operator and the arrow operator on the same P1.
Because we wanna get
Because we want to get
address, not information.
Bora,
about
what I am
the
asking is, how could this happen? On the same object, I am using both the dot operator and the arrow operator. Is it an object or is it a pointer? How could this happen? We never did this before. See, if I have a money object, money M1, I would say M1 dot get cents, and this is fine. If I say M1 arrow get cents, this is an error message, right? This doesn't happen, okay? If I have a money pointer, MP new money, I would say MP get cents. This is fine, but if you say MP dot get cents, this is bad. But this guy is doing both. This guy says that P1 dot get and P1 arrow show. How could this happen?
Can I say?
Sure.
Because P1 is not pointer. I think this works like class,
Yeah,
and get is a member function of
that
P1.
class. How about arrow?
Overloaded operator.
Exactly, yeah, exactly. Because if I look at the documentation of the shared pointers, it works like that, okay? Operator arrow and operator dereferencing is defined on the shared pointers, okay? And get is the member function of that class, shared pointer class. So I am using those stuff in there. Where is my code? Okay, here it is. Okay, so p1.get will get you the pointer itself. Okay, will get you the pointer that I printed out. P1 show calls that show function of that object. And I have another pointer which will be the same as P1. That means that that object that I have created with new will have a count of 2 now. Okay, it will have a count of 2. Okay, it will have a count of 2. And when you say P2 show, it will show exactly the same thing. And P1 get and P2 get will give me, okay, are they going to give me the same thing or different things? P1 get and P2 get. Get, remember, get returns you the pointer that is kept inside the shared pointer.
It's the same.
It's the same thing. Yes, they will return the same thing. Then I will use the P1 dot use count and P2 use count. They will both return 2 because 2 things are being 2 pointers are pointing to the same object. P1 dot reset resets P1. P1 says that I am not going to point to that object anymore. P1 dot reset. Well, in that case, with the P1 dot reset, in that case, only P2 is going to point to that object. So P1.get is going to return maybe null to you, but P2 use count is going to 1, and P2 get is going to be the same as the one above. And these are the results. Can I run this? Run code and see output. Can I edit this? Yeah. Okay. So I like to do something. What would I like to do? Yeah. Okay. I like to do this. I like to find tilde first. Do you guys know where tilde is? Tilde. I am looking for tilde. Okay, I know how to do it. Let's go there. And now I have tilde. Okay, good. Tilde A. And now I have tilde A, and this is my function. And I am going to copy here and do this. And a destructor. I am going to call the destructor. So where do you expect this destructor to be called? Okay, so let's look at the code before this destructor. Okay, let's look at the output. Output is like at the beginning when you say p1.get, it's going to give you the address of that object. Okay, 1C41C20, and then I call the show. It says a show. That's fine. Then another one and p2 show. P2 show is going to run the same thing, and p1 get and p2 get are going to give you the exactly same address. Then both the use counts are there, okay, 2 and 2. And then when I reset p1 get will return null. p2 use count is returning 1, and p2 get is going to return you the same address again. So when I make this change, I edit this destructor. Where are you gonna get this destructor message?
When program ends.
When the program ends. Why? Because PT is going to be killed. When PT is going to be killed, the reference count of that object is going to drop to 0, and the destructor will be called. Let's run it. What? Okay, I'm going to sign in then. I am going to sign in. So it's going to, come on. Can I? Maybe I should paste it to, where did it go? Did my code, am I going to write the same thing again? It is still loading. Shared pointers. So the signing up, was that a good thing in terms of speed? Reload it again. Stop and reload. Where is the run thing? Where did it go? It is still loading. You know what? I am going to copy this whole damn thing and I will open up my There is something wrong with my computer, maybe. I am doing too many things. What? What was the name of the Windows Explorer? Okay, maybe just edit, gedit, mem.share.cpp. vi share.cpp, and I am going to insert this whole program. Ooh. Why did I get everything like... Okay, here it is. Run it. So this is the output. Request compiling. And I got it back, right? So this is the output. And I am going to edit it and run it. Tilde a cout Okay, now run code and see stuff. Request compiling. As you see, the destructor is at the end. Okay, so we did something, right? So the destructor is at the end. Everything is done. So question, how about this one? Am I still editing it? Yes, I am editing it, right? Control C and Control V now. Okay, question. P2 gets the value of new A. Now tell me what I am going to see. So this was my output before. The destructor of the object is called at the end of the function because nobody is pointing to it. So now tell me what I am going to see. How many destructors are going to be there? 2, right? Because I have 2 news. But tell me where the destructors are.
The first one is after line 20.
You have 20 seconds.
Line 22. The first one is
Sorry, I
after
turned off my
20.
sound. Just tell me again. Who is talking? Bahadur, tell me again from
I'm
the beginning.
talking.
Okay.
The first one is after 23, and the second one is when the program ends.
Yeah, the first one is going to be after 33, you mean, right? Not 20. 33. Yeah. And then at the end of the program. Why? Because P2 is now pointing to a new object, okay? So the previous object, nobody is pointing to the previous object, so it will be destroyed. When I reach the program end of the program, since PT is going to be destroyed, then I will call my destructor at the end. So let's run this. Compile. No match for operator. What did we do here? Where is my P2? Okay, P2 new A. Okay, to assign a P2, you need to use what? Assignment is the assignment of a new, okay. Swap, get, operator, unique, owner before. So make shared, specific functions. Assignment operator works with the other shared pointers, okay. So maybe I should do this. Maybe I should do, where is my code here? Okay, so let's do shared pointer P3, okay, and new A, and then P2 is now pointing to P3. This will work. Okay. So assignment directly didn't work. Assignment is for the assignment of two shared pointers, not the from one new operator to other one. I mean regular pointer to a shared pointer. So let's run this. Okay, one of the destructors is here, the other one is at the end. Okay, two of them. What is this 2? 2 is there because 0 is the use count for the P1. For the P2 it is 2 because for both P2 and P3 is pointing to the same object. By the way, this is different than that. Why? Because this is a new object. Okay, good. So, but there should be a way of assigning a pointer to a already created shared pointer. Other than reset, what would I do? Get pointer. Is there no set pointers? No. Use count, unique, operator, bool, owner before. Swap. Okay, it swaps the contents. Make shared. Yeah, okay, I think this one. Make shared. It's a global function, I guess. I don't know. I couldn't find it. I don't remember how you set it. But this is a dangerous thing, actually. What we are doing here is a dangerous thing. Why? Because if you keep intermixing your regular pointers with the shared pointers, you will be in trouble. Once you are in the land of shared pointers, you stay in the shared pointers. Okay? Don't intermix them. Okay? Once assign your pointer when you create your shared pointer, and don't do anything about the regular pointers. Maybe that was a design decision to prevent that kind of usage. go back and forth between the regular pointers and the shared pointers. Okay, so that's shared pointer. There is another version of this smart pointers in C++, which is called unique pointer. Unique pointer is like a shared pointer, but it doesn't share anything. It just, if you are a unique pointer, okay, your reference count could be at most 1, and you will not let anybody else to point to the same object. Okay, you will not let anybody point to the same object. That's called unique pointer. And I think this class, okay, I think this class was better way of using the unique pointers, because I am not going to let anybody else to point to my array A. So this would have been a better choice of smart pointers, unique pointer. Again, I don't do the deletion done automatically. By the way, this will not work in this case, because I cannot assign this new to that one. I need to do a new shared pointer and make that assignment that way. Okay, so that's it. I guess I didn't have time to talk about move semantics. That means that I will talk about move semantics at the beginning of next class, and after that I will start talking about Java. Are there any questions? Are there any questions? Okay, if there are no questions, then that's it for today. I will see you on Monday morning.